int I is equal to 1, I less than n, I is equal to I into 2. This is my for loop, and I'm incrementing my p here, and I'm writing other loop for int j is equal to 1, j less than p, and j is equal to j into 2. In last class, we had seen that if we are having I is equal to I into 2, then the time complexity for that is we go off log n. We have seen this already in previous class, and here also we say that this is a big O of log p. I am considering this as big O of log p. Here we are having log p. I am taking that this. I am considering that p is equal to big O of log n. I am considering the above for loop as p is equal to big O of log n. Now here I can write log n, so that here we are getting the time complexity for whole the process is, let us see, here my p is equal to big O of log n. Here my time complexity for the other loop is log p. I am writing the log p value which is at the first step. I am writing p value as big O of log n. Big O of log. Here I am writing log n. So the time complexity for this code is big O of log n. So this is the time complexity 0, I less than n, I plus plus. This is my other pseudocode, and I'm taking for of int j is equal to 1, j less than m, j is equal to j into 2. I'm incrementing I plus plus. For j, I'm incrementing j into 2. And here I'm writing one statement and closing my loops. Here we are getting, for I, we are getting like this. For I, we are getting like this. It means here for I, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, and so on. Yeah. For j, we get at first j is equal to 1. If I consider n is equal to 5, at first j is equal to 1. J is equal to 1. When j is equal to 1, then j less than 5. It means 1 less than 5. J is equal to j into 2. 1 is equal to 1 into 2. It means at first we are getting 2. After that 4. After that 2 3 is 6, 8, 10, and so on, and so on, and so on, 2 power n. As we have seen this example already, the time complexity for this code is the time complexity for I iterations. Time complexity for I iterations is n times. Okay. Then time complexity for j iterations is big O of log n. So the total time complexity is equal to n into big O of log n. n into big O of log n. So we can call it as n log n. Big O of n log n. Sorry. Big O of n log n. So we call the time complexity for this code as big O of n log n. Here it is taking n times, and here it is taking log n times. So the time complexity for this code is big O of log n. Up to now we had discussed some of the pseudocodes, right? So for the basic pseudocodes we need to remember. The basic pseudocodes we need to remember. The basic pseudocodes we need to remember, or the basic pseudocodes we need to remember are, first one is for int I is equal to 0, I less than n, I plus plus. The time complexity for this is big O of n. The second one, for int I is equal to 0, I less than n, I plus is equal to 2. The time complexity for this also big O of n plus 2, and we can say it as big O of n, big O of n. For this, for int I is equal to 0, I into I less than n, I plus plus, we can treat it as big O of root n, big O of root n. Here I need to write root n. Here I am writing big O of root n, and I am taking the other pseudocodes which we have discussed. For of int I is equal to 0, I less than n, I is equal to I by 2. The time complexity for this is big O of log n. For of int I is equal to 0, I less than m, I is equal to I into 2. For this we are getting big O of log n. So these are the basic pseudocodes which we need to remember. So that I had once again revised for you all. Thank you for listening to my class, and I hope that you got complete idea about the time complexity. Thank you very much for listening to my class. Thank you.